Welcome to Edunovus practical session of qualitative analysis. Qualitative analysis is concerned with identification and confirmation of radicals present in an inorganic salt. A simple inorganic salt contains a cation or a basic radical and an anion or an acidic radical. Our aim is to identify and confirm the cation and anion present in the given salt, for which we follow systematic procedure.
Qualitative analysis. In qualitative analysis, the given compound is analyzed for the basic and acidic radicals, that is, the cations and the anions in the given compound. The common procedure for testing any unknown sample salt is preliminary test. Acidic radical, that is, anion identification and confirmation. Basic radical, that is, cation identification and confirmation. Here, we consider the soluble salts containing the following cations and anions. Cations: lead, copper, aluminium, ferrous, manganese, zinc, cobalt, calcium, barium, magnesium and ammonium. Anions: carbonate, chloride, bromide, iodide, nitrate, acetate, sulfate. Now, let us go through the systematic procedure for qualitative analysis of inorganic soluble salts. Preliminary test. In the preliminary test, we find the leads which help us in identifying some cations and anions. Color. First thing in the preliminary test is color. Even though it is not much reliable, it is certainly helpful in identifying some colored cations. So, let us examine the salt.
Let us examine the physical appearance of the salt. Firstly, color of the salt. If the given salt is in blue color, it may be a copper salt. If the given salt is in light green or bluish green color, it may be a nickel salt. If the given salt is in buff color or flesh colored, it may be a manganese salt. If the given salt is in pink color, it may be a cobalt salt. If the given salt is in light green color, it may be a ferrous salt. And if the given salt is in brown color, it may be a ferric salt. Finally, if the given salt is in white color, it indicates the absence of colored radicals, namely copper, nickel, manganese, cobalt, ferrous and ferric.
Dry heating. In dry heating test, we heat small amount of salt in a dry test tube. We can gather quite valuable information from this test. On heating some salts, they undergo decomposition and evolve the gases, or it may undergo characteristic changes in the color of residue. So, let us perform the dry heating test on the salt.
Let us see the action of heat on the given salt. Take a small amount of given salt in a clean and dry test tube and heat it using Bunsen flame. Here you can see the liberation of colorless vapors. Take a small amount of given salt in a clean and dry test tube and heat it using Bunsen flame. Here you can see the liberation of colorless gas with pungent odor. If these vapors gives white fumes with glass rod dipped in ammonia, this infers that the given salt may contain chloride anion. Take a small amount of given salt in a clean and dry test tube. Heat it on Bunsen flame. If a colorless gas with pungent smell and which gives white fumes with glass rod dipped in dilute HCl, it infers the presence of ammonium cation in the given salt. Here you can see the formation of white fumes with glass rod. This test infers that the given salt may contain ammonium cation. Take a small amount of given salt in a clean and dry test tube and heat it using Bunsen flame. If reddish brown vapors are liberated, it infers that the salt may contain nitrate anion. Here you can clearly see the liberation of reddish brown vapors. This test infers that the given salt may contain nitrate anion. Take a small amount of given salt in a clean and dry test tube and heat it using Bunsen flame. If any decrepitation of the salt is observed, it infers that this given salt may not have water of crystallization. Here you can clearly see the decrepitation of the salt. Take a small amount of given salt in a clean and dry test tube and heat it using Bunsen flame. you can see the change in color of the salt from yellow to brown. In this way, if the salt is brown when hot and yellow when cold, it infers that the given salt may contain lead cation. Take a small amount of given salt in a clean and dry test tube and heat it using Bunsen flame. Here you can see the change in color of the salt to pale yellow. In this way, if the salt is yellow when hot and white when cold, it infers that the given salt may contain zinc cation. Take a small amount of given salt in a clean and dry test tube and heat it using Bunsen flame. If a white residue is formed which glows on heating, it infers that the given salt may contain magnesium, calcium, barium, strontium or aluminum cation. Here you can clearly see that this residue is glowing slightly. This test infers that the given salt may contain magnesium, calcium, strontium, barium or aluminum cation. Take a small amount of given salt in a clean and dry test tube and heat it using Bunsen flame. Here you can see the change in color of the salt from blue to white. In this way, if the salt is white when hot and blue when cold, it infers that the given salt may contain cupric cation. Take a small amount of given salt in a clean and dry test tube and heat it using Bunsen flame. Here you can clearly see the change in color of the salt to blue. In this way, if the salt is blue when hot and pink when cold, it infers that the given salt may contain cobalt cation.
flame test. In the flame test, we need to prepare a paste by mixing the salt with the concentrated HCl. After the paste is prepared, it is introduced into the flame with the help of a platinum wire. Here, we take concentrated HCl because salts react with the concentrated HCl and form volatile chlorides which import some color to the flame. Flame test gives us some reliable information about the presence of certain basic radicals. So, let us perform the flame test to the salt.
Reliable information about the basic radical present in the salt can be obtained using flame test. In this test, the given salt is to be made into paste using concentrated HCl. The purpose of taking only concentrated HCl is the basic radical of the given salt converts to volatile chloride which readily responds for the test. Now, let us prepare the paste of the given salt using concentrated HCl. Now, this paste is to be introduced into the flame using platinum loop. If the color of the flame changes to brick red, it indicates the presence of calcium free radical. Here, you can see the appearance of brick red color in the flame. This indicates the presence of calcium radical in the given salt. Similarly, if the color of the flame changes to apple green, it indicates the presence of barium free radical. Let us check it once. Here, you can see the change in color of the flame to apple green. This indicates the presence of barium free radical in the given salt. If the color of the flame changes to golden yellow, it indicates the presence of sodium free radical. Here, you can see the change in the color of the flame to golden yellow. This indicates the presence of sodium free radical. In a similar manner, let us check the color of the flame for another given salt. If the color of the given salt changes to bluish green, it indicates the presence of copper free radical. Here you can observe the change in the color to bluish green. This indicates the presence of copper free radical in the salt. Here we need to convert the given salt into paste. This appearance of bluish white color in the flame indicates the presence of lead radical in the given salt.